Hey guys, how are you doing tonight? We're going to continue our lessons on triangles and the relationships within the triangles. And we're going to talk about bisectors in our triangles. Um, so you're going to learn quite a bit of vocabulary today. We're going to learn what concurrent means, what a point of concurrency is, a circumcenter, and an incenter. And then we're going to look at the properties of the circumcenter and an incenter. Um, for your classwork, you are going to have to construct angle and perpendicular bisectors, so you might need to review that. So what's concurrency? For something to be concurrent, it means that we have three or more lines that intersect in one point. And for that to be that, they're called concurrent. So these line segments, yes, I know they're not lines, but these line segments that I've drawn here are concurrent. And where they intersect right there would be our point of concurrency. So a point of concurrency is where they intersect. These points of concurrency for the different segments that we can draw on a triangle all have special names, and they're all going to have special characteristics, and that's where we're going with this. Okay. First of all, we have a perpendicular bisector, and is just the perpendicular bisectors of the sides of our triangles. So I'm going to draw my right angle in here so that we can say that those are, and what else would I need? I'd need to say that these are congruent, these are congruent, and then these are congruent. And then that would make these three segments, this one, and this one, perpendicular bisectors. Now the characteristics of a perpendicular bisector is that they are concurrent. They intersect in this one point right here, and that point is called a circumcenter. Okay, and it is equidistant from the vertices. So here are my vertices of my triangle. I'm going to do this in a different color so that it makes it a little easier to see. Okay, here, here, and here, those are all equidistant, or those are all congruent to each other. And the other reason we call it circumscribed is I can't really draw very well. Maybe I can. Here we go. A circle, and that circumcenter is the center of the circle that goes through the three vertices. Okay. So I want to kind of look at some stuff, and I'm going to show you, we're going to, maybe, it's going to let me leave here. It's supposed to take me there we go, to a hyperlink. Guess it wasn't too pressing hard enough or something. And this is Geometers Sketchpad, and I wanted to show you. Here I've got a triangle, and I've got the angles measured because we're going to look at the three different kinds of triangles: an acute, an obtuse, and a right. And we're going to look at that point of concurrency. I have drawn in one perpendicular bisector. I'm now going to show you, because I know some of you guys don't always believe what I say, and I'm going to draw the other, or construct the others. So this Geometer Sketchpad is a pretty powerful tool. So you guys see I just constructed the midpoint, and now I'm going to select the midpoint and the side, and I'm going to construct a perpendicular through there. And we know that's a perpendicular bisector because you guys watched me. I found the midpoint, and then I constructed a perpendicular line. So now I'm going to select segment BC. I'm going to construct a midpoint, and then I'm going to construct the perpendicular. So I've selected the point and the line, and I'm going to construct the perpendicular line. Now notice that all of these 3 points intersect, and I'm actually going to find the intersection here. So with me constructing it, it's always going to, that point's going to be there. So right now I've got an acute triangle, and you can see that my incenter is inside. Okay. So here's my acute triangle, still acute, okay, and my triangle is on the inside. So for an acute triangle, and let's see if I can flip them and do some other things, you can see that my circumcenter is on the inside. Okay, see what else I can do. Let's flip it. So I flipped it, I've moved some vertices, and you can see by the angles it's still an acute triangle. Now let's pull out B. So I pulled out this point, and now you notice that angle ACB is now 114 degrees, so that's an acute or an obtuse triangle, and it looks like my circumcenter is on the outside of that triangle. Okay. So let's pull it around and see. It's still obtuse. If I pull it and move it around a little bit, still obtuse, flatten it out, still obtuse, and that point is still on the outside. All right. Here, notice that it falls on that line that looks like it's pretty close to a right triangle. So what I did was I constructed my right triangle. You can see that it's 90 degrees. So I constructed it by making perpendiculars, and definitely my circumcenter, which is this point right here, is on that side. If I move it around, okay, I've still got a right triangle. Okay, I've changed sides, I've changed ratios, I've done all kinds of things, and that circumcenter is on one of the sides. Looks like it is always on the hypotenuse. See, drag some more. So yeah, at this point, it's always on the hypotenuse. All right, so we're gonna make some educated guesses, some conjectures, and those are actually true, and we've kind of proved them by using this Geometers sketchpad. So what does that mean? That means that, okay, my circumcenter, when I have a right triangle, is on the hypotenuse. Okay. In an acute triangle, it is inside the triangle. And on an obtuse triangle, it's outside. So there's a good little way to remember there. Okay, outside, obtuse. So that at least alleviates one and helps you to remember. All right. So we want to find now, for an example, the coordinates of the circumcenter of triangle ABC. If we know that A is the point -4, 5. So there's point A. Right? B is -2, 5. It's right there. Okay, and then label that. C is -2, -2. Now I said that at the beginning of the video that you would have to construct. This would not be the case when you really have to do one. So I've drawn my triangle. It's not really pretty, but I should know some things about perpendicular lines, right? Perpendicular lines, remember, their slopes are opposite reciprocals. So if I'm looking at AB, if I'm going to make it perpendicular, then it's going to be, AB is horizontal, so this is going to be a vertical line. So it's going to be a vertical line, and the length of AB is 2. So that means that my midpoint is going to be right here. So I'm going to kind of try to draw it in carefully. Didn't draw it very well. Okay. And then probably the easiest is going to also be side BC. That is vertical. So its perpendicular would be horizontal, and my midpoint is going to be 1.5 between them because that length is 3. So it's going to be right about here. Okay, and I didn't draw these. It's hard to draw in here very well. And then lastly, if I want to make a perpendicular with a horizontal line, we don't really, or with a diagonal, I really don't need to do that because finding the intersection of the two is going to be enough to find my perpendicular bisector is here. If I had to sketch in the third one, that should actually be more at 1/2. So it looks like right now we are at -3 and +3.5 for my circumcenter. So if I start at that point, my slope of AC, looking at this picture, I'm going down 3 and to the right 2. So my slope would be -3/2, and my slope of my perpendicular would be +2/3. So we learned that in an earlier chapter, and you also did it in Algebra 1, and I know that because I'm doing it right now in Algebra 1. So if I went to this point and I went down, or let's just go up to 1, 2, and over 3, 1, 2, 3, that would be my perpendicular bisector of side AC. So just different ways that we could find that perpendicular using things that we know. Now again, angle bisectors are going to bisect each angle, and they're also going to be concurrent. Okay, and that point ends up being equidistance from the sides. Okay, and remember in an earlier lesson I said that the distance is going to be the perpendicular. Okay, so it's from a point to a perpendicular. So the distance is there, and it's concurrent is the point is equidistance from all of our sides. So XP is going to be congruent to PZ, which is going to be congruent to YP. And we call that in center, and we call that because this would be a center, since it's equidistant of a circle drawn inside. So that's an in center. Okay. So if I look at my diagram, I can see that all of my angles are bisected because they're congruent. The distance, I've got my perpendiculars so that I know that all of these, and they're not really looking scaly, but I've got BG congruent to FG, which would be congruent to DG. So if I know that GB is 8x minus 7, and I know that GD, so here is GB, here is GD, so they're supposed to be congruent. Okay. So if I want to find GF, well, I know that GF is congruent to all of those. So I can solve my equation, add 7 to both sides. I'm going to get 8x equals 5x plus 15. And if I subtract 5x from both sides, I'm going to get 3x equals 15. If I divide by 3, x equals 5. Okay, and I'm going to take the simplest for me. I guess it doesn't really matter because actually we can use it to double check. 8 times 5 minus 7 is 40 minus 7, which is 33. Or if we put it into the other 5x plus 8 here, it should still be the same. So just a quick way to check to see that you've done this correctly. 5 times 5 plus 8 is going to be 25 plus 8, which is again 33. So GF is going to be 33. So today we talked about things being concurrent, 3 or more lines that intersect. Where they intersect is that point of concurrency. The circumcenter is the point of concurrency for the perpendicular bisectors of a triangle. And the incenter is the point of concurrency for the angle bisectors of your triangle. My perpendicular bisectors are from that circumcenter to the vertices are congruent, the incenter to the sides and the distance being that perpendicular are going to be the same. If you have any questions, hit me up in class tomorrow. You guys have a great evening. And I will see you tomorrow.